Imagine the following scenario. An individual enrolled to the IBM as a basic user with sufficient rights to run simple application tasks, but this user has no command line capabilities and no special authorities. This individual tries to find a way to gain additional rights using non-conventional methods and eventually succeeds. Please note that this is a very realistic scenario, as fraud is very often committed by insiders. Now let's see how the QRadar 400 and QRadar combined solution can help you gain the needed visibility into what just happened.
In this scenario, we will use a regular user profile with no special authorities nor command line access. As you can see, the current 5250 session we opened using this user profile displays a fixed application menu. This user is not permitted to enter commands as the limit capabilities parameter of this user profile is set to yes. Using standard protocols, we will now try and elevate this user's authorities. So, let's try running remote commands using FTP. We are now connecting to the IBM. Let's run the display user profile command, which will display the list of all the user profiles we have authority on. It clearly failed as shown on the screen. Let's now try the display object description command, which should yield a similar result to the previous command. It clearly failed too. Based on what we just tried, the limit capabilities attribute does also apply to FTP. That's good news. Let's now try another method. RMTCMD is part of IBM Access for Windows. Each remote command type will require to sign on. Oh surprise! The command was issued. Compared to FTP, the security control process is definitively different. I am now allowed to run commands even though I am a limited user. The display object description command should have populated a file named U in the QGPL library with all the users we have authority on. Let's run the run query command so that we can review the content of this file. The command is successful. I should therefore get a build file as a result. Let's go back to the 5250 session. Let's press the attention key and then option 1. This build file is there. Let's press 5 to display it. We now see 3 internal system profiles, of course our own profile, but also 2 others, Bruce and iConsole. It looks like these 2 others have not been secured correctly. Let's see now how much power we can get from these profiles. Let's start with iConsole. We are now running the display user profile command for iConsole. Let's now gain access to the related build file. We are now reviewing the details of the profile. The user class is SecOFR, but more importantly, the special authorities are all there. Bingo! We can use this user profile now. We are now running a command to change our own user account in order to grant ourselves all object and give ourselves access to command line. Let's use the submit command to run it in batch mode under the user iConsole. It looks like the job was submitted. In order to see if it was successful, we can simply sign on again and see if we can run the command to access our file directly. It works perfectly. We are now a super user. Now let's turn to QRadar to demonstrate how we would know about this individual who found a way to gain additional rights. We will also use QRadar to gather intelligence and to draw a clear, complete and contextualized picture. Let's first focus on the following Cilasoft event. As you can see from the raw content of this event, iConsole granted GM Basic LM super user privileges. Please note that the QRadar DSM does not parse the specific name of object field, yet we also need to work with this portion of the Cilasoft event, as we need to track this GM Basic LM user. If not present in QRadar, we should create a custom event property, unless it is already created, for example as part of a specific app from App Exchange. We are now checking that we have already defined this custom event property as object_name. We can check that this custom event property works by reviewing the event in QRadar. We can now see the object name custom field properly displayed. We do need a rule to detect this condition, but as we want to track those fraudulent users, we have created a row reference set we called suspicious users, as displayed on the screen. Please note that multiple rules can use the same reference set. A rule can either add data to a reference set or just perform a lookup. Let's now look at the rule we simply called superuser privileges acquired on IBM. This rule detects events from the log source type Cilasoft QRadar 400, whose high-level category is authentication and low-level category is user account changed. This rule participates to an offense. We also need to configure the rule to perform the following two responses. The first one is to generate an alert, also known as dispatch new event. The second one is to add the detected user to the reference set we previously created. Upon saving the rule, we can now check the content of the reference set. The specific user GM basic LM was added to this reference set. We can also see that we do have an offense for this user. We can now search for all the events related to the users currently included in the suspicious users reference set. This can be achieved by using the following advanced search. The advanced search groups the results by event name. We therefore see two types of events: the alerts generated by our rule, and the events that were detected by this rule. Ideally, we should also track the user accounts used by each individual, tracked through their IP address. For this, we created a reference map of sets we call track users. The reference map of sets can be created by using QRadar's RESTful API interface. Let's now return to our rule to see how we configured it to populate the reference map of sets collection. We are using this rule to add the destination IP and username from the detected events to the track users reference map of sets. Please note that we are also using the two rules highlighted on the screen to add the detected source IP address and username to the same reference map of sets. Now let's return to the API interface to query the content of the track users reference map of sets. Scroll down on this page, and specify track users as the name. Click on the Try It Out button. Let's now review the return data. From the content of the reference map of sets, we clearly see the user accounts used from the client machine whose IP address is 192.168.5.201. Let's now consider the following advanced search and its output. We can clearly see that some individuals logged into the Linux workstation usually used by GM. This is definitively of great concern and would need further investigation, as one could imagine that someone hijacked GM's workstation to then start a user session to the IBM. In this video, we cannot possibly demonstrate the many powerful possibilities offered by QRadar. We have obviously only scratched the surface.